Hi everyone, in this video we are going to see how to find the equation of a circle when the endpoints of a chord is provided and also the inscribed angle is provided. Let's suppose we have a chord AB and the coordinates of A and coordinates of B are provided, and also it has been given that this chord inscribes an angle of theta degree or theta radian. So in that case, we have to find the equation of the circle. Now here I have one situation in the diagram, but could this be the only situation here? Well, if you think about it, we could have another situation like this, and here again we could have another circle where it's the same chord with the same endpoints, and also it inscribes an angle theta, and here we see the dotted green color circle is the second circle. So actually there are two possibilities. So that means when we are provided with the coordinates of the endpoints of a chord and the size of the inscribed angle, then actually there are two possible equations, and that's what we're going to derive in this video. First, let's find out what is the slope of the chord AP. Well, its slope will be y minus y sub 1 over x minus x sub 1, and let's call it m sub 1. Let's call this slope as m sub 1. Next, what would be the slope of the chord BP? Well, there again, if we call it m sub 2, that will be equal to y minus y sub 2 over x minus x sub 2. From a previous video, we know that tangent of theta is equal to m sub 1 minus m sub 2 over 1 plus m sub 1 times m sub 2, the absolute value of this quantity. I have already created a video on how to find tangent of theta between two lines when their slopes are provided. So in this case, we know the slope of the line segment AP and BP, and also we know the angle between them theta, and here we can use this formula. Then tangent of theta will be equal to absolute value of m sub 1 minus m sub 2 over 1 plus m sub 1 times m sub 2. I have shared the link in the description. Feel free to watch that video. So from here, if we remove the absolute value sign, then can we say that m sub 1 minus m sub 2 over 1 plus m sub 1 times m sub 2 will be equal to plus or minus tangent of theta? There are two possibilities. And next, we are going to plug in the values of m sub 1 and m sub 2, and then we are going to create the two equations. So from here, we can say that m sub 1 minus m sub 2 can be written as plus or minus tangent of theta times 1 plus m sub 1 times m sub 2. And then let's plug in the values here. I have plugged in the values of m sub 1 and m sub 2 as derived up above. Then the equation going to look like this. And next, let's simplify the equation a little bit. On the left hand side, the LCM would be x minus x sub 1 times x minus x sub 2, and then in the numerator we are going to get y minus y sub 1 times x minus x sub 2 minus y minus y sub 2 times x minus x sub 1. And on the right hand side, we are going to have plus or minus tangent of theta times, here again on the right hand side the LCM will be same, x minus x sub 1 times x minus x sub 2, and in the numerator we are going to get x minus x sub 1 times x minus x sub 2 plus y minus y sub 1 times y minus y sub 2. Now you see the denominators on both sides are equal, so they will cancel out each other, and we are going to be left with something like this. On the left hand side numerator, we have y minus y sub 1 times x minus x sub 2 minus y minus y sub 2 times x minus x sub 1 is equal to, on the right hand side we have plus or minus tangent of theta times x minus x sub 1 times x minus x sub 2 plus y minus y sub 1 times y minus y sub 2. And there, if we use the plus sign for one equation and the minus sign for another equation, we have actually two equations hiding in this combined equation, and that will actually represent the two equations of the circles when the endpoints of the chord and the inscribed angle are provided. Next, let's take an example. Let's suppose we have an example like this that says find the equations of the circles having a chord with endpoints a 2, -3 and b 6, 7. A and b are the endpoints of the chord, and also the chord inscribes an angle of 45 degree. So what are the given information? X sub 1 will be equal to 2, y sub 1 will be equal to -3, x sub 2 will be 6, y sub 2 will be 7, theta will be 45 degree, and from here tangent of theta will be tangent of 45 degree, and that is equal to 1. Now let's plug in the values of x sub 1, x sub 2, y sub 1, y sub 2 and tangent of theta in the equation that we just derived up above. So here I have simply substituted the values of x sub 1, y sub 1, x sub 2, y sub 2 and tangent of theta. So our equation going to look like this, and I'm still carrying the plus and minus sign there because this equation actually represents two equations. So if we simplify this little bit, the equation going to look like this, and then I'm going to remove the parenthesis, then the equation going to look like this, and in the next step I'm going to remove the remaining parenthesis. Our equation is going to look like this, and then after further simplification our equation is going to look like like this. And from here we are going to take two possibilities. The first possibility, let's call it equation number 1. Here we are going to take the plus sign on the right hand side. So our first equation could look like this. The left hand side is exactly as is, and on the right hand side I am using the plus sign. And if we bring everything to the right hand side, then we can write it as x squared plus y squared minus 8x minus 4y minus 9 minus 10x plus 4y plus 32 equals 0. And if we simplify that little bit, the equation is going to look like x squared plus y squared minus 18x plus 23 equals 0. And that is the equation of one of the circles. So this is one of the possibilities. And also we have another possibility by using the minus sign on the right hand side. So here if we use the minus sign on the right hand side, then the equation would look like this, the one that I have in the white color. And if we remove the parenthesis, then the equation will look like this. And next I am going to bring everything to the left hand side. Here the equation going to look like this. And from here, if we do a little more simplification and reorganize, the equation finally going to look like this: x squared plus y squared plus 2x minus 8y minus 41 equals 0. And that is the equation of the second possible circle. When the endpoints of a chord and the inscribed angle are provided, we have actually two possibilities, and these are the equations of the two possible circles. I hope everything made sense. Thank you for watching. See you in the next video.